Hello friends, welcome again to this session, and today we will discuss full depth reclamation of asphalt layers. It is also called full depth recycling or FDR. FDR offers a significant cost-effective method for the pavement with premature distresses like raveling, cracking, rutting and general loss of riding quality, which cannot be addressed by replacing the surface layer with another thin bituminous layer. It is useful in general for all types of roads, but very effective for low volume roads where thin bituminous layer is provided. The FDR is a recycling or pavement rehabilitation method where all of the asphalt pavement section and a predetermined amount of underlying base material like WBM, WMM or GSP is treated to produce a stabilized base course. It is a cold recycling process in which different types of additives such as asphalt emulsion and chemical agents such as calcium chloride, Portland cement, fly ash and lime are added to obtain an improved base. In its simplest form, the FDR consists of in situ pulverization of existing pavement and underlying layers, uniform blending of pulverized materials, grading it and then compaction. It is more permanent solution for pavement repair and rehabilitation than overlay and routine maintenance. FDR uses all the existing roadway materials no matter the current condition, and therefore it is the greenest construction process available. The applications of FDR process are many. It can be used when flexural stresses in wheel lanes are observed, or asphalt distress due to low base failure, pavement condition index going below 2, or when there is excessive rutting or alligator cracking in the asphalt surface, or excessive patching more than 20%, when there is a need to widen the roadway, or there is a need to correct the asphalt pavement cross slope in conjunction with other needed distresses to be corrected, or where the cost of overlying granular material is very high. The process of FDR is to use road reclaimer or recycler to pulverize an existing asphalt pavement and a portion of the underlying base, subbase and or subgrade as required to meet the requirement of the designated stabilized and homogeneous base thickness depending upon the existing subgrade strength and designed traffic category. Blend the pulverized material uniformly with an additional stabilized material such as cement or cement with additives to provide an upgraded homogeneous material. The third, the stabilized material is then compacted in place with different compacting equipment, and the result is a stiff stabilized base that is ready for a new rigid or flexible surface course. So above this stabilized base we provide a thin or thick bituminous layer. FDR is very suitable for parking lots, low volume roads, secondary roads and city roads, but can be used on interstate highways as well. There are four disciplines of FDR. One is pulverization, the second mechanical stabilization, third the chemical stabilization and the fourth is bituminous stabilization. In case of mechanical stabilization, aggregates are added to meet the deficiency of the grading, whereas in case of chemical stabilization, Portland cement or lime or fly ash or cement kiln dust or lime kiln dust or maybe combination of these or some commercially available stabilizing agent is used to stabilize the layer. Whereas in case of bituminous stabilization, emulsified asphalt or foam binder is used. But the chemical stabilization with Portland cement is the most common type of FDR stabilization in the country. The pulverization is the most economical FDR discipline, and in this case in situ pavement layers and predetermined amount of underlying materials are pulverized and mixed. and the moisture is the only additional material which is added to achieve the required density. Here in pulverization, no stabilizer is used. This process is used when base, subbase and or subgrade deficiency are not apparent, and anticipated quality of pulverized base cores is sufficient enough to support the anticipated loads after surface cores placement. And this base course is acting as a sub-base for an engineered full depth pavement system. In case of mechanical stabilization, we add some imported granular materials like crushed virgin aggregate, or it may be asphalt pavement milling material which we call the RAP, or crushed concrete. So it can be addition of either virgin aggregate or recycled material. And it can be performed with a single pass or with multiple pass depending upon the requirement. And mechanical stabilization is best suited for low to medium traffic volume pavements exhibiting the typical surface and minor base defects which are associated with an aged, oxidized and overloaded pavement. Chemical stabilization involves the incorporation of one or more of the chemical stabilizing additives like Portland cement, lime, fly ash, calcium chloride, or any other blend or chemical stabilizer commercially available. There are several benefits of chemical stabilization. It allows otherwise unsuitable on-site materials to be turned into a strong structural base or sub-base material for an asphalt pavement. Pavements rehabilitated with chemical stabilization are the pavements that would typically require substantial full depth repair or undercuts or total reconstruction. The typically best suited pavement for chemical stabilization are low to high traffic volume pavements showing severe distress caused by heavy wheel loads on base, sub-base and or subgrade materials with insufficient strength. This table provides guidelines for selecting the type of stabilizing material for different types of soil and soil aggregate based material. Now this gives you the gradation of the material, that is soil type, as per unified group classification system and as per ASTRO group classification system. So in case of material ranging from well-graded gravel to inorganic silt and very fine sand, Portland cement or lime fly ash blend is preferred. The soil which other than these materials, or you can say the soil having higher PI value or falling in the group of A4, A5, A6 and A7, here lime kiln dust or pozzolana material is considered to be better, and hydrated lime or quick lime is considered a good stabilizing material for soil with medium to high compressibility. The aggregate soil mixture should satisfy the gradation as given in this table. The maximum size of aggregate is 53 mm and nominal size of aggregate is 37.5 mm, and it should follow the gradation as given in this table. In case of bituminous stabilization, it involves the incorporation of bitumen stabilizing additive like emulsion or formed asphalt. And benefit of this stabilization is that it is cost-effective method of improving the strength of a reclaimed material while reducing the effect of moisture. It is more flexible than other base course materials and chemical stabilizers. It offers superior fatigue characteristics and is not prone to cracking. And typically best suited for medium to high traffic volume pavements exhibiting the typical surface and minor base defects associated with an aged, oxidized and overloaded pavements. One of the key steps in the full depth recycling operation is the mix design. And the mix design process includes sampling the material from existing carriageway to determine the thickness of the existing asphalt and aggregate base and sub-base layers and classifying the types of existing pavement materials that will be incorporated into the FDR base layer. The reclaimed sampled material is tested in a laboratory where an appropriate cement content, optimum moisture content, and maximum dry density are determined to achieve the desired strength and durability. One of the elements that can affect the overall FDR mix design is the amount of the base or sub-base material that will be incorporated in FDR layers. Mix design for FDR involved several steps, and the first step is to obtain the field samples from every 1 kilometer for determining the variability in the material for deciding the number of mix designs to be carried out. Second, determine the gradation of the reclaimed sample, and if necessary, additional materials may be added to satisfy the gradation requirement as given in this table. And I told you that the maximum size of aggregate should be 53 millimeter, and it should conform to the grading as given here. The fourth step is for mixed design, 3 different cement contents testing may be selected. So you design the mix for 3 trial cement contents. Determine the optimum moisture content and the maximum dry density of mix using each cement content. Then cast 150 millimeter cubical specimen at each cement content at maximum density and OMC for determination of unconfined compressive strength at 28 days. Cylindrical specimen of 100 mm diameter and 200 mm height can also be used to determine UCS value, but the results are to be converted to 150 mm cube by multiplying the result with a correction factor of 1.25. In fact, other combinations of height to diameter can also be attempted as per IRC SP 89 2018, and the appropriate correction factor should be applied, but the result is obtained in terms of UCS of a cubical specimen. Then seventh step is to carry out 12 cycles of wet and dry durability test on each specimen at each cement content. And then you find out what is the loss in the weight after wet and dry. Then we make a plot between the unconfined compressive strength and cement content and wet and dry durability test result versus cement content on graph papers to determine the desired cement content. According to one document available, the maximum allowable weight loss after 12 cycles of wet and dry should be limited to these values depending upon the soil type. Again, for granular soils and up to poorly graded sand, the loss is 14%, and for clay and medium to high compressibility, it is 7 to 10%. After that, create a mix design report with the established cement content and moisture density information. So that is the complete mix design for FDR. The design report should contain the gradation of combined mixture, including the content of wrap, liquid limit, plastic limit, and PI value of combined material if it is required, then maximum dry density and OMC graph of the FDR mixture, UCS at each trial cement content, wet density of UCS test specimen before and immediately after moist curing period, and recommended cement content as a percent of dry material, and also recommended CCS content as per mix design. Now here, in addition to this, the graph between UCS and cement content and the graph between loss in weight with cement content should also be provided with the design report. There are certain precautions to be adopted in case of full depth reclamation. It is not suitable in areas with drainage problems such as saturated subgrade or inadequate drainage system to direct water away from the pavement structure. Full depth recycling is not the solution of all pavement distresses. Agencies should consider the condition of the existing pavement and reason for distress. And like all reconstruction methods, the FDR with adoption of stabilizing agent and cement to achieve the required strength of pavement requires an engineering pavement evaluation as a part of project selection as well as implementation of established quality control practice during construction. So friends, thank you very much for watching this video. I hope you liked it. You can write your observation in the comment box.